Alright, so we're in week 2, Tuesday. Any questions about anything we've done so far? Any of the assignments? Anything at all? Going once? Going twice? Okay, so for Tuesday, we're not going to do anything new. The only new thing that I'm going to tell you about is how to convert between the different number systems. You have a couple of assignments that have to do with that. So let's just, I'm just going to jump straight to these assignments and let's have a look at them real quick. Okay, so this assignment right here asks you to convert these numbers from 47 and 23, two different numbers, from decimal to binary, right? And then there's another one is convert from binary into decimal. And you can use Word to write your answers, save and upload the file. And here's an example. So the example is, let's have a look at it. So the first thing I want to introduce is your regular decimal number system, which we all take for granted, right? We all use it, but maybe not all of us know how it works. So there's 10 numbers in the decimal number system. It goes from 0 to 9. And whenever you write some kind of a number like 365, what really happens is you're telling it, get that number, and then you're going to do 300 plus 60 plus 5. That's your 365, which is the same as writing 3 times 100 plus 6 times 10 plus 5 times 1, which is your 365. Or another way to write this thing is saying 3 times 10 to the power of 2, 6 times 10 to the power of 1, 5 times 10 to the power of 0. Okay, why is this a 10? Because it's a decimal number system. There's 10 digits in it, right? So that's why we're doing the power of 10. So 10, it always starts at 0, and then it's a 1, and then it's 2. What's 10 to the 0? Anything to the power of 0 is 1. What's 10 to the 1? Whoops. Anything to the power of 1 is just that one same thing. So 2 to the power of 1 is 2. 10 to the power of 1 is 10. 10 to the power of 0 is 1. 2 to the power of 0 is 1. Any number to the power of 0 is 1. Okay? And then 10 to the power of 2, that's just 10 times 10. 10 to the power of 3 is 10 times 10 times 10. Okay? So those are the powers. So this same mental gymnastics applies to the binary number system. So what is the binary number system? The binary number system is just like the decimal, well, kind of like the decimal, except it only has 2 digits. There's the number 0 and then the number 1. Why do we choose that number system? Because the computers can only understand on or off, and it's easy for us to say, okay, well, off is going to be 0 and on is going to be 1. Right? And based on that, we can do all kinds of math. Okay, so it's important for you to understand how to go from one number system into another number system. All right, so let's say, for example, you have this binary number right here, and we're trying to convert this thing into a decimal number. So what you have to do is you're going to put the 2 different powers underneath it. So the first digit is going to be 2 to the power of 0, second one 2 to the power of 1, third one 2 to the power of 2, fourth one 2 to the power of 3. Okay, if you forget your powers, right, 2 to the 1 or 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 2 times 2, which is 4, 2 to the power of 3 is 2 times 2 times 2, which is 8. And what actually happens is these are just doubling. So it's going to be 1, 2, 4, 8, 16, 32, 64, 128, 256, etc. Okay? And this stuff is used in IP addressing. So whenever you have like a network, and let's say you're trying to go to the google.com, the google.com is a lot of times associated with an IP address like 1 something 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 something, right? So, okay, any questions? So the next thing we're going to do is we're going to multiply these different powers, right? 2 to the power of 3 is 8, 2 to the power of 2 is 4, 2 to the power of 1 is 2, right? And we're going to add up all these numbers. So 1 times 8, 0 times 4, 1 times 2, 0 times 1. And once you add up all these different numbers, 8 plus 0 plus 2 plus 0 is your 10. That's your decimal. So binary 1010 is decimal 10. Questions? Make sense? Okay. There's another way we can do this. Well, not another way, but there's a way for us to go from a decimal number into binary. Okay? And it goes like this. So let's say I'm trying to do the number 61, right? So I'm converting 61, and I'm trying to convert this thing into binary. Okay, so the way it goes is you get the 61, and you're going to divide the 61 by 2. What is that? It's 30.5. You ignore the decimal piece, and you bring down the 30. Right? So then you're going to do 30 divided by 2, which is 15.0. You ignore the decimal, you bring back the 15. 15 divided by 2 is 7.5. You ignore the decimal, you bring down the 7. Divided by 2 is 3.5. You bring down the 3. 3 divided by 2 is 1.5. Right? You bring the 1 down. 1 divided by 2 is 0.5. And when you get to the 0, you stop. Okay? So, now how we're going to figure out what is the number? You're going to look at these remainders here, the ones that we're ignoring, the 5, the 0, the 5, the 5, the 5, and 5. Anytime you see a 5 after a decimal, that is going to be a 1. So this is a 0.5, 1, 0.5, 1, 0.5, 1. This is also 1. The 0 is a 0, this one is a 1. And then you read this number from the bottom up. So that decimal, 61 decimal is 11101. Okay? And you can verify these numbers if you have like a Windows. It's part of the calculator. If you have a Mac, it's more of a pain to do it, but it's also in the calculator in there. Okay? So one more time, let's say I'm trying to convert this. So any questions on this stuff, first of all? We're good? Make sense? Okay, the next thing is, let's say, and then this is basically what I just showed you, right, before. Let's say we want to convert binary to decimal. So it's just another exercise from binary to decimal. Let's say I have this one right here, 1011. So what I'm going to do is I'm going to put the number on top of it or on the bottom of it, whatever you want. You're going to put the different powers. And it's just, for as far as binary is concerned, it just doubles. So you're going to do 1, 2, 4, 8. If you have another number, it's going to be 16. Another number is going to be 32, then 40, etc., 64. Okay? So we multiply the blue times the red. So 8 times 1 is 8. 4 times 0 is 0. 2 times 1 is 2. 1 times 1 is 1. And you add up all these numbers, and it turns out to be 11. Okay? Question? We're good? All right. So this is one of the assignments that you have to do, right? You have to do this for a couple of numbers, right? The numbers are 47 and 23, so you're going to convert these decimals into binary, and then these two numbers, 11011 and this, from binary to decimal. Follow the examples that I gave you, and you'll be fine. Okay? So that's the first one. The next one that I have for today is this hexadecimal conversions. So hexadecimal is another number system. So decimal is 10 numbers, binary is 2 numbers, hexadecimal is 16 of them. Okay? And that one is used also in IP addressing. So the most modern IP addresses today, they're changing from binary, or there was like a binary representation underneath it, into hexadecimal. And the reason for that is because you can make a whole lot more IP addresses. And if you don't know what an IP address is, it's how you identify yourself on the internet. It's why you shouldn't go download something that you're not supposed to, because then you can easily be identified by that. Okay? In fact, if you go in there, you can do what is my IP, and it's going to show you what your IP is. There's a public IP, there's a private IP. Anyone know how to change this thing? VPN. Right? So if you're going to go download something that you're not supposed to, get yourself a VPN client. Right? Now I can go in there and say, oh, all right, let me go. I'm going to choose location. let's say I'm going to be in Switzerland. And then I turn this thing on. And sometimes it doesn't show the correct thing, but let's see if it shows it. Connecting. Anyway, once this thing is on, yeah, there you go. Let me try to see this again. What is my IP? I'm going to search again. And different number. Okay, there's some ones that will actually show you the map of where you are. Okay, so it is easy for you to fake your IP address. Okay, it's just, you got to use a VPN client. And so unless you use this, you can't go torrent things, okay? Otherwise your IP, your internet service provider will tell you, oh, this guy with our IP has been using this. How the VPN works is it creates a tunnel. It encrypts all your traffic between and your VPN provider, and then so nobody knows what happens between you and the VPN provider. And then after that, it's a different IP address. Okay, so now you know. Anyway, but these IP addresses, any one of these different IP addresses are actually in binary. That's why the biggest number that this can go to is 256. Right? Remember how there are multiples in 2? 1, 2, 4, 8, 16, 32, 64, 128, 256. So if you have 8 bits, the biggest number you can make out of 8 bits is 256. Okay? So what is a bit? It's the smallest piece of information that the computer can understand. That's the on or off. So it's either 1 or 0. Okay? So that's where it comes from. All right. So let me go back to this and show you the hexadecimal thing. So the hexadecimal conversions are similar to, well, there is an example in there. So for the assignment, you just click this link and you're going to see this. All right? So the hexadecimal numbers are from 0 to F, right? So you have your regular numbers from 0 to 9. And then you have some letters, okay? If you were to represent these in decimal, it's from 0 to 15, right? It starts at 0, it ends at 15, but there's 16 of them, okay? Because we got the 0 also, okay? So let's say I'm trying to convert this number, or this hexadecimal number, into decimal. How does it go? First, what you have to do is you're going to grab this here, right? The F is what number? F is 15. You put that in there. Then the next one, the D. What is the D? D is 13. You put that in there. Then you get the next one, the 5. What is 5? 5 is 5. Stays the same. Then the next one, E. E is 14. Right? So you put that in there. The last one is a 1. And you put that in there. And then the next piece here, the 16, is your base. Right? Why is it 16? Because we got 16 numbers, just like the power for the binary was the base for the binary was 2, right? And then the powers go 0, 1, 2, 3, 4, and you can just plug those into a calculator. You don't have to do it in your head, right? And you get some decimal numbers. All you have to do is add up all these here, all the decimals, and your final sum is your decimal, right? So the hexadecimal number 1E5DF is 124,383. Okay? So that's one way to do it, or that's the way you convert from hexadecimal into decimal. Any questions? If you get stuck or whatever, or you need another example, I made up another example underneath it. Okay? Now, what you have to do is you're going to convert the following hexadecimal numbers to decimals, show all the work. Okay? Don't go and plug it into a calculator and tell me what they are, because, yes, sir.
Does it ever go past F? Or is that
F is the highest. Yes. If you have the biggest number, the biggest 1, 2, 3, 4, 5-digit hexadecimal number will be the F, right? Just like what would be the biggest binary number? 1, 2, 3, 4, 5 binary number. 1, 1, 1, 1, 1. Okay? When you run out of ones, you got to go add another one to the left, basically. Okay? So let's say if I run into the biggest number I have is, let's say I have an F. If I add 1 to that, what am I going to get? You're going to add another. These are all going to go to 0, and then you're going to add another one to the left of that. So that'll be the next biggest number after the FFFFF. Okay? Next one is decimal to hexadecimal conversions. And again, same business. You have your hexadecimal numbers, you have your decimal numbers. Okay? You have to do this similarly to what we did with the binary. You have to divide. So you start with, let's say we're trying to convert 300 into hexadecimal. 300 divided by 16 is 18. You multiply 18 times this number. It's actually, by the way, not exactly 18. So if you do 300 divided by 16, you're going to see that that's 18.75. You ignore the decimal piece and you just put the whole number, just like we did with the binary. Okay? And then you multiply this number here, the 18 times 16. Right? So 18 times 16 is 288. Then you subtract 300 minus 288. You're left with 12. And then we'll go down. You get this number here, the 18. You divide that by 16. It's not exactly 1, but you ignore the decimal. You multiply 1 times 16. That's a 16. Then you subtract that, minus 18 minus 16. You're left with a 2. You bring back the 1 down, right? 1 divided by 16 is a 0. 0 times 16 is 0. 1 minus 0 is 1. And you stop there. And now you have to convert these numbers here, right? You have to convert these numbers into hexadecimal, right? So 12 decimal is hexadecimal C. 2 decimal is hexadecimal 2. 1 decimal is hexadecimal 1. And then you read them from the bottom up, just like you did with the binary, right? So 300 decimal is 1, 2, C hexadecimal. Any questions? Make sense? Okay, and if it doesn't, there's another example underneath it, and you can use that to get going. So what you have to do is then do the math for these, convert the following decimal numbers to hexadecimals, show all your work, just like I have shown you here. And last but not least is just do some of these in the calculator. You can use the Windows calculator, you can use whatever calculator you can find, right? And just show me what is this in binary, what is this in binary, what is this, and then what are these binary numbers into hexadecimal. And that's that. We got it? Okay, so these are just the number conversions that you have to do for this week. Other than that, the only other thing that I wanted to go over is, the only new thing beyond that is making a random number. Okay, so I'm going to show you how to make a random number, and you're going to have to make random numbers in this class quite a bit, so get comfortable with making random numbers. It's not that complicated. Okay, so if you click on this random number business here in this link, you should see this, and this shows you how to make a random number. So there's a couple of things you have to include in your regular program. So let me just turn this off. I don't want to be in Switzerland anymore. Quit it.
When you do that, you're hopping over to Switzerland for all of your calls, right?
When I go, yeah, everybody thinks I'm in Switzerland right now.
Yeah, but your web traffic is going
Is going through, well, my web, yes, yeah. They think I'm in Switzerland as far as anybody's concerned. And my traffic, I'm going to my VPN server in Switzerland, basically. My VPN company has different servers all over the world. And that's really interesting, by the way. Has any of you traveled around the world and try to access like Netflix or something? Have you noticed something? The movies are crap in the United States. If you go to like say Peru or something, you got to realize that their selection of movies is crazy. It's like you have a lot more movies on Netflix in Peru or Mexico than you can have in the United States because of all the copyright laws and whatnot. So you want to watch Netflix through, and see all kinds of extra movies, turn on a VPN, program. The trick is that now Netflix has been getting smart about it so that they track, they have like a list of all these different servers. So the reason I chose, so if you have like say a server in Switzerland, they might know about that server, right? So they might say, oh, well, hold on, we know you're using a VPN, so no, and you can't access any of the information. but they don't know all the servers, right? So you just have to go and pick some obscure server in like Venezuela or whatever, and then you're gonna get better, you're gonna get better movies than you would in the United States, for real. Okay. All right. So I would not do my important transactions over VPN. So let's say if I'm gonna go into my bank account, I'm not gonna go and type in my password and username over the VPN, because even though my traffic is getting encrypted between me and my VPN server so that nobody else in the world can figure out what's being sent and received, the VPN server itself can log my information, right? So I'm not trusting their encryption for my personal data. But if I'm going to download something and I don't want the rest of the world to know what I'm downloading, VPN. Okay, now you know. Okay, so all right. So random number. Going back to a random number business. So before you saw that there's a couple of things in the basic program, right? This is your basic program in C++, right? Include IOStream using namespace std, int main, and then return 0. That's like the bare bones of every program you're going to do. Okay, so what we're going to do is we're going to add a couple more of these. So one of them is I'm going to include time.h. The other thing I'm going to include is and don't ask why it's changing colors, it just does. Okay, because the reason it's not changing colors is because it might think that I'm not using them for anything. Whatever. stdlib.h is the other library that I need. So I need these two libraries in order just to make a random number. You have to jump through a lot of hoops just to make a random number. Now the next thing you want to do is you're going to say int iseed. The iseed is just the variable name I make up. Could be whatever you want. Is equal to int time no, right? And you don't have to understand what all these little steps are doing, right? Just press the believe button for now. If you want me to explain to you what's what, I can do that too. But you don't have to understand it just to make a random number. The next thing you want to do is srand iseed. Okay? So this, I'll tell you a little bit. So this basically, what I'm doing is I'm pulling the system time. I'm getting my clock, some big number, whatever. I can go in there and show you, but it doesn't matter. And then I'm feeding the clock, my system time, into the srand, which is a generator. It generates a list of random numbers. Okay? It will always generate, srand will always generate. So if I went in there and I put 1, srand will always generate the same random list of numbers. So it might be like 1, 5, 15, whatever. And every time I run my program, it will always make a 1, 5, 15, same random list of numbers. If I want to change the random list of numbers, I just give it some different number in here. So the different number is just my system time. Anyway, you need these two lines to make a random number. And the actual random number business is something like this. So let's say I'm going to say int random num is equal to rand modulus 4. Okay? So what is this going to be? It's going to be a random number between 0 and 3. And I put that in a comment in this little thing that I have in there. So let me just copy it. Okay? Okay, so this thing underneath it makes a random number between 0 and 3. If I run it a bunch of times, it's going to make me a bunch of numbers between 0 and 3. Sometimes it might mess with you and just make the same number over and over again a couple of times, just to trip you to make sure that you're paying attention. But yes.
And these are all integers, so there's no decimal, right?
No decimal. Yeah, we're going to be making random numbers, just integers. Okay. All right. So what I'm going to do now is. I don't know, let's say, so this is a random number between 0 to 3, right? But let's say I want to make a random number between something else. So I'm going to show you, first of all, cout random num, and I'm going to run this thing and see the number. Right, there you go, it's 2. If I run it again, 3, again, 2, 1, there you go. So it makes random numbers. Does it include the 0? It should. It should be a 0. There you go. We got a 0 too. It was really nice to make all the random numbers you know, all the different ones, because sometimes we'll just go 2, 2, 2, 2, 2, just to piss me off. Okay? So, anyway, these are not real random numbers because somebody wrote a program to generate these random numbers. Even behind the scenes, this srand, which is the one that generates the list of random numbers, is just some algorithm that somebody wrote. So we're calling these pseudo-random numbers. If you want real random numbers, you have to look at like, you know, look at an atom and look at like the electrons bouncing around and that kind of stuff, you know. Just truly unpredictable events. Those will make you random numbers. But we're not doing that. Who cares? It's close enough of a random number. Okay, so if I wanted to make a random number from 0 to 3, I do modulus 4. And if you remember, I gave you like this speech about how we use the modulus, right? So you basically, if you do modulus x for whatever number, you're going to get a number between 0 to x minus 1. And that's what we're doing here. Okay, that's how the modulus works. And this kind of stuff is also used in encryption and hashing. Okay, so let's see if you're getting it. So let's say in there I want to go and I want to make a random number from 0 to 10. How am I going to do that? I'm going to say random num is equal to rand modulus what? 11. Okay, good. You're paying attention. So that's how you make a random number between 0 to 10. All right. Now, let's do one more, just because I know you got it, but okay, maybe not everybody. So let's say I want to make a random number from 0 to 26. What do I do here? 27. Okay. All right.
What do you find in between 12 and 24?
That's the next one that I'm going to do. So now let's say somebody said here, we want to do a random number between 12 and 26.
What do you do 13 and 27?
What do I do where? What am I going to change this to? Or how do I do this? Yep.
Is it going to be just find the difference in another?
Close. There is something. So the easiest thing to do is basically I am going to start with this number right here, right? The 12. I'm going to put in front right here. I'm going to say 12 plus. So, and then I'm going to make a random number between, how much do I need to add to 12 to get 26? Huh? 14, right? So how am I going to make a random number of 14? 15. Okay? So the general formula is, let's say I have int min is equal to 100 and I have int max is equal to 200, right? So I want to make a random number between 100 and 200. It's going to go like this. Random num is equal to min plus rand modulus max minus min plus 1. Right? Is that what I did here? 26 minus 12, 14 plus 1 is 15. So this right here is your general formula to make any kind of a random number in C++.
Is it either or is it you have to do both?
What do you mean, either or?
So is it int 100 and then the max? Oh no, I see.
Got it?
Yeah, I see what you did.
Yeah. So you put the min first, and then you add rand, and then you do modulus, and then in parentheses you do max minus min plus 1. Okay? That's how you make random numbers. That's all there is to it. Okay? So all this other stuff was just to get to the bottom of this and show you that this right here, you could use this for any one of them. You want to make a random number from 0 to 10, change min to 0, and max to 10. Okay?
Is the SRAND required as a setup?
SRAND is so that SRAND will make, yes, it is required. So SRAND makes a random list of numbers, and then what RAND does is, let's say I have, when I do SRAND, let's say I'm going to have numbers like 1, 15, 25, okay? if I go in there, so this is the list, and there's going to be like a lot of them, right? The SRAND generates. As soon as I say rand, as soon as I do rand, that pulls the first number from the list. If I do rand again, that's going to pull the second number from the list. If I use rand again, it's going to pull the third number from the list. So every time I use rand, it pulls one of these numbers from the list, and this list itself is being generated by SRAND. And SRAND will always, let's say for example, if this was 1, then this list is always going to be the same digits in the same order. Okay, if I wanted to change the digits and the order of these digits, then I go and I I just feed it the system time, which changes every time I run the program. Question?
And what's the line right above that? The IC equals.
This one is basically I'm telling it get the system time, put it in an integer format into this variable, and then feed this variable into SRAND. And SRAND is a function. We haven't done functions yet, but that's what's happening. I'm just sending the value into the SRAND function.
It's like a method?
Yeah, method. Method is what we call them in Java. Yeah. Procedure, methods, yeah. Okay. Any questions? Random numbers? Not that hard, I hope. Okay, you're going to have to do a whole bunch of these random numbers all over the place in this class, so get them right. Okay, get comfortable with them. Okay, so that's an example of random numbers. I already showed you the hex and the other one. So what we're going to do is, I guess I can go through the little programs that I have as assignments for today, P11. Right, so you're going to go in there, you're going to type up an example from the PowerPoint, and I even put the picture in there so you don't have to go through the PowerPoint. Okay, that's the first one, so just type it up, get it running. Show me that it runs on the bottom of your code using multi-line comments, and you're done with that. The next one is quarters, dimes, nickels. So what you're going to do is you're going to ask the user to enter number of quarters, number of dimes, number of nickels, and then you're going to give them the total number of cents that is equal to. All right? Any questions?
In going back to the 11,
Yeah.
in your sample dialog 2, in your sample, the name of your alter ego is Mr. Parker.
Yeah.
Are you truncating the Bojangles part?
So this here is middle name. Bojangles. Where's the Bojangles from?
That was just the entry the person did, was just Mr. Bojangles.
Oh, okay. Is Mr. Parker? I think it's not showing. It's not showing one of the things that were entered. Remember how I was telling you that there's issues with doing a CN on a string? I think that's like an example of a look that doesn't work. Okay, so don't worry if you enter what you're supposed to enter and then it doesn't show you both of the things you entered, right? So what's happening is it's doing this. It's getting the first piece of the string, and then anytime it encounters a space, it ignores everything after the space. So if you want to do an input of a string, there's other ways to do it. There's like a get line with a CN and then the variable name, but I'm not going to go there. It's not worth the overcomplication. Not that important of a concept. It's just, there's ways to enter a string. Let's not do that. Okay? If you take Python, if you take Java, they're a lot more user-friendly, especially Python. Python is it's a breeze to write a program in Python. If things don't work, it'll tell you, hey, I forgot this. Okay? And in C++, if it doesn't work, it'll just crash on you, or it'll just look weird and do all kinds of weird things without telling you what happened. Okay? So strings are just not an important thing for this class. Okay, the next one is compute distance. So you have a formula. I'm giving you the formula here. Distance is equal to acceleration times time squared divided by 2. Okay? I don't know if this is a free fall or something. Whatever. Okay, yeah, this is the distance. Okay, so you're going to assume acceleration is 32 feet per second. So instead of acceleration, you just type in the number 32. And instead of time squared, how are you going to do squared in C++? let's say I have, I'm going to go in there, I'm going to do, I have, let's say, int time is equal to 4, right? And I want to do cout time squared, okay? If I try to do time squared like this, it's not going to work, okay? You can see that C line is already highlighting things. It doesn't like it. The reason why it's not liking it is because you cannot do this to a C++ program. You can't do it in Java, can't do it in Python. Most programming languages, you just can't do powers that way. Easiest thing to do, don't even worry about anything else, just do times times time. All right? There you go. That's powers, that's time squared. Make sense? Okay, so this is your hint for P13. So, oops. Hint or P13 hint, right? If you have time squared, you do it this way. Okay. Any questions? Okay. The next one, and make sure, notice what I say. Program must run as shown below. So make sure you play around with your output so that you output the things the way that I'm showing you here. With the asterisk, with the parentheses, with the little thing here, I forget what it's called, whatever, right? Show it the way I'm showing them to you. Okay? So that's that one. The next one is random number. All right. So you already know how to make a random number. You need to check to see if a random number is odd or even. All right. So how are you going to do that? Let's remind you. So this is P14 hint. Okay. So let's say I have random num. I don't want to give you the whole thing. You make the random number. So the random number is between 10 to 25. Right? You're going to show it to the user. And then let's say you have int num, and I have this thing is equal to 5. Okay? If num modulus, see if any of you remember, modulus what is equal to what? 2 is equal to what? For even? 0. So if you don't have a remainder when you divide something by 2, it must be even. Right? So if that's true, I'm going to say cout num is even. Okay? And let's do the endl. I forgot to do double quotes. It's not going to be good. Okay? So that's that. Questions? All right, let's run it. Hopefully it works. Yeah, it doesn't show anything. Let's change this thing to 6. There you go. 6 is even. Okay? All right. So that's your hint for number 14. Now the next one I'm going to do is 15. Okay, I lied to you. There's more I got to tell you. All right, ASCII. You don't know what ASCII is, so I got to tell you about ASCII. What is ASCII? ASCII is the numeric representation of every key on your keyboard. So the letter A has its own specific number. The letter uppercase A has a different number than the lowercase a. Right? So it's case sensitive and they all have different numbers. And I give you the ASCII table right here. So if you want to zoom in, it doesn't look that good, but whatever. Let's say we have, this is uppercase A, which is 65. Uppercase B is 66. Right? These are the lower cases. It will look better when you look at it yourself, I hope. Otherwise, you can just Google ASCII table. You're going to see that all over the place. Right? So lowercase a is 97. Uppercase a is 65. Right? So everything on your keyboard, even the delete key and the little tilde, has its own ASCII. What are the ASCII values? These right here. Right? These are the decimal representation, decimal numbers. And notice they also have hexadecimal. This one right here is the hexadecimal representation. So we learned about hex. Now you know what that is. Okay? So what do you have to do? The assignment asks you to ask the user to enter a letter and then let them know if it's an upper or lowercase letter, if it's a number, or if it's something else. Okay? Do I give you any clues in there? No, that would be nice. Okay, so let's do a hint on this. So let's say I'm going to do input of a character. So let's try this. I'm going to do not int, char L, right? It's a letter. And I'm going to do cout, enter a single, and so this is your hint for 15. P15 hint. So enter a single letter, right? And I'm going to do a cn L, okay? And then the first thing I want to do is I want to make sure it works, because I don't believe anything, right? So I'm going to go do, say L is equal to, or just you entered L, okay? And maybe an end L. Oops, if I can spell it, and L. Okay, let's run it. Enter a letter, uppercase O. You entered, go away, entered O, right? Okay, so it recognizes what I entered. So the next thing I'm going to do is, I'm going to show you the ASCII of this thing. Cout, the ASCII is, let's put that there. So the ASCII is int L. So I'm going to force this thing to turn itself into an integer, which is going to be its ASCII representation. Let's try it again. And let's try it for something that we already know. So we said that uppercase A is 65 in this blurry table. And let's go back in there. So I'm going to run this thing. Enter a letter, uppercase A. ASCII is 65. Cool? Okay, so what are you supposed to do? The user is going to enter something, right? And you're going to tell them if it's an uppercase letter, lowercase letter, a number, or something else. So I'm going to show you the uppercase letter, and you got to figure out the rest. Okay? So I'm going to go in there, and if my letter, if L, let's do extra ones. One. Yeah, I'm going to do an end. Okay, so if my letter is greater than or equal to 65, that is the letter A here. So letter A is 65. The last one, letter Z, is 90. So if they entered any letter between uppercase A to uppercase Z, it will be a number between 65 through 90. So I go in there, okay, if my letter is bigger than or equal to 65, and my letter is less than or equal to, what number did I say? 90. Okay, I'm going to say, let's do the curly brackets, cout, uppercase. Okay, and L, and let's try it. I'm going to go in there, I'm going to run this thing. Okay, enter a single letter, lowercase a. No, okay, it's 97, but that's not in between these two values. Run it again. Okay, enter a single uppercase letter, D, uppercase. Okay, so you have to go through the ASCII table and then look at the different numbers and write the respective ifs accordingly. Questions? We're good? Okay, so those are your ifs. You know, practice with ifs. And by the way, make sure you catch up with these assignments as soon as possible, because next thing we're going to do on Thursday is loops, I think. All right, so you should be comfortable with the ifs and elses before we get into the loops. Otherwise, you're going to look at me and you're going to be like, what are you doing? I don't understand any of this stuff. Okay, so make sure you get your hands on, get it done. Okay, so that's 15, practice with ASCII. 16, rock, paper, scissors. Okay, in case you don't know how that goes, paper covers rock, rock breaks scissors, scissors cuts paper, and there's also a tie if they match. So you're going to do something like this. You're going to ask the user to enter numbers. Again, we're just going to stick with numbers. You can ask them for letters if you want. That's fine. Just kind of try to stay away from strings. Okay? Because even comparing strings in C++ is not, you can't really compare them with like the equal. You got to do all kinds of other magic. So let's not go there. Okay? So it will go like this. So let's say this is your hint for 16. So this is P16 hint. Okay? So we go in there, and I'm just going to do this message. Oops. Copy this. Alright, so let's say I'm going to have int player 1 and int player 2. Well, let's put them both in the same one. Player 1, player 2. Right? And I'm going to ask the user to enter, or you're basically going to play against yourself, unless you want to make a random number between 0 to 3, and then you can play against the computer, which is fine too. But for simplicity's sake, just play against yourself first. Okay, if it works when you play it against yourself, then you can make it random number, and you can even have the computer play against itself. Okay, but first test it with specific numbers so that you make sure. Okay, so I go in there and I do a cout. This. Alright, so I'm going to say, okay, player 1, enter rock, paper, scissors. Alright, I'm going to do a cn, player 1. I'm going to do the same thing. Copy this. Paste. Alright, player 2. Same business. Okay? So now the next thing is determine the winner. So there's 3 ways for player 1 to win. There's also 3 ways for player 2 to win. And I guess you could say there's 3 ways to tie also, but we can generalize that, but I'll let you do all the 3 for practice if you can't figure it out. Okay, for tie. Okay, so 3 ways for player 1 to win. Let's say, and I put them in there, rock, paper, scissors, so you know what's what. You can make your life easier by making some variables, some extra variables. I'm going to put them right here. I'm going to say, okay, hold on. Int, let's add them right here. Rock is equal to 1. Paper is equal to 2. Scissors is equal to 3. That way I don't have to go in there and say, well, if player 1 is 1 and player 2 is whatever, I'm just going to use the words rock, paper, scissors. So, 3 ways for player 1 to win. First one is, or one of them, if player 1, let's say, if my, let's do 2 of these. Okay, so if my player 1 is equal to rock, and what does player 2 need to be in order for the rock to win? Paper. So if this one is equal to rock and the other one is equal to paper, then you can tell them, let's do the curly brackets, cout, P1 wins, and you can tell them rock, wait, rock beats paper? Are you sure?
No, it's
Scissors. Scissors. Okay, so rock breaks scissors. Make sense? Let's do another one. And okay, so by the way, keep in mind that since I'm going to have a whole bunch of ifs, it looks like I might have 9 of them, I'm going to shorten my code a little bit. Since there's only one thing inside of my if, or under my if, I don't need the curly brackets. So I'll skip the curly brackets. Let's do the other one. I'm just going to copy this whole thing here, because I don't want to type again. Okay, and this time, I'm just going to erase this. So let's say player 1 is equal to, I don't know, pick one. One of the other 2. Paper. All right. This one is paper. What does player 2 need to be in order for the paper to win? Rock. All right. So that's the other one. All right. You go in there, grab this thing, copy it, paste it under. You can tell them player 1 wins. This time paper covers rock. Okay? So you can write, there's one more way for, write the third way for player 1 to win. And let me show you one of the the one for the player 2. What do you think you're going to do? You grab this whole thing. You can write it up the whole thing if you want. But all you got to do is switch to player 1 and player 2. So player 1, now it's player 2. Player 2 is now player 1. and you just change this little label here. Player 2 wins, rock, break, scissors. Okay? So I'll write the rest of the ifs. There's a few more. And that's your hint for the rock, paper, scissors. Any questions? Okay. So that's the P16. And the next one is P17. More coin conversions. So you already had the user enters things. Now we're going to do slightly different thing. And this time I was nice enough to give you a clue, right, of what to do on this blurry picture, which will look better on your screen, I promise. And if it doesn't, let me know. Okay, so it goes like this. Let's say you have a cashier that sucks at math, right? And they're going in there and the customer, you have to give them 66 cents and they're going in there and give them like 66 pennies, right? You want to write a program that is going to break it down into the fewest possible coins that they give to the customer. So if they're supposed to give out 66 cents, your program is going to calculate, okay, we're going to have 2 quarters, which is 50 cents. We're going to have 1 dime, which is 10 cents, 1 nickel, 5 cents, and 1 penny, 1 more cent. When you add all these up, 66 cents. How are you going to do that? It's right underneath, right? So I'll write it. So P17. Okay, so I'm going to do hint P17 hint. Okay, so let's say I have int total coins. Okay, and you can ask the user, cout, enter total coins. Okay, and then in there you're going to do cn total coins. Okay, and you can show it to yourself, but let's not, right? I'm assuming it works. Okay, so the next thing I want to do is I'm going to go in there and I'm going to have another variable, and I'm going to call this one quarters or quarters. Okay, so what is my quarters? Quarters is equal to my total coins divided by what? 25. Okay, and I do cout quarters is equal to quarters. And they'll, okay, let's see if that works. Yeah, here's your letter. Okay, you gotta do enter rock, scissors, whatever. Okay, total coins, I want to do 66. Hit it. And there you go, there's 2 quarters. Okay, now the next thing you want to do is you want to take away the number of quarters from your total coins, so that then you can calculate with whatever's left what is the number of dimes. So you're going to go in there and you're going to say, all right, my total coins is now equal to its old value minus quarters. And it doesn't know what quarters is, right? Quarters is just a variable you made up. So it's going to be quarters times what? 25. All right? And that's it. And then you can use these remaining coins now to calculate your dimes after that. All right? Here. Dimes is equal to, and I don't have dimes, but here you go. We can do the dimes. Dimes is equal to total coins divided by what? 10, right? Etc., etc., etc. So what you could do is, let's say if they entered some small number, if they entered maybe 4, right? Don't show them 0 quarters, don't show them 0 dimes, use some ifs in there. So if the quarters are less than 0 or equal to 0, right, don't show them. If there's no dimes, don't show the dimes. Okay, so you could do that. I'm not sure if it's part of the program. It isn't. Oh yeah, there you go. I have a clue in there basically. So if you have a Q, if the quarters is greater than 0, only then do you want to calculate, you want to show the quarters and subtract the quarters from your total. Make sense? All right, so that's your clue, and I put it in the notes too. And let's see what else we got. Last one. Okay, now this program, last semester one student told me that it offends him. I'm not kidding. So it's a program that calculates what's your, I guess, sign, And he told me that, oh, this offends me because of spiritual reasons or whatever. I was like, you know what, buddy? I almost told him off. I was like, use fruits and vegetables. Okay? So if it offends you, use fruits and vegetable names. Okay? So it goes like this. You're going to have some kind of a birthday, right? And based on that birthday, you have some zodiac sign. Okay? So let's say you were born between the March 21st through April 19th. You would be this one, right? Aries. All right. So how does that going to go? Let's go in there. And man, I forgot to record this, didn't I? Shit. Yeah, there's no lecture for today. There's no video for today. Damn it. All right. It's just the lecture notes. I forgot to hit the record button. Okay. So the next one today is P18. So let's say you have int. We're going to have. Let's assume that the user enters these. All right. So I'm going to go in there. I'm going to say, okay, int month is equal to 3, and int day is equal to, I don't know what, is 22, 23, right? So basically they're born after March 21st, which is going to make them Aries, right? Okay, so I basically go look at my program, right, or my problem, and how is it going to go? So if my month is equal to 3, that's for March, right? And we're going to have to throw in a bunch of parentheses in there because that's how C++ is. Not cool at all. And your day is what? Less than or equal to what value? Oh no, it's got to be greater than or equal to what? 21. And if you want to be very particular, you can go look at how many days are in freaking March. I don't know. Oh, there's 31. Okay. So, and we can add another one. And my day is less than or equal to 31. Right? That would be Aries. So I can go in there and say, all right, see out Aries. Okay? That's that one. Okay? So if I go and I run this thing, it's going to ask me for a bunch of stuff first. All right. 1. Okay. Whatever. Aries, right? So it recognizes that. But there's another way for this to be Aries, and that is if we are born before April 19th. So let's do another one. And by the way, you can combine both of them as an OR, make it a longer line. So if my month is equal to what? 4. And my day is greater than or equal to what? Okay, let's do the less than or equal to 19. And the day is what does it have to be greater than or equal to? 1, right? For it to be a valid date. And that would also be Aries. Okay? So there you go. Now you got to go write 11 more of these. So it's an excellent practice with and ands and ors. If you want to, you can combine both of these lines. Let me grab this thing, stretch it a little. So I'm going to grab this, cut the whole thing, put an or in there, paste this there. I'm going to have to throw another set of parentheses around it, like this. And now I can get rid of this. So it's all on the same line. Okay? But let's leave it the way it was, because lines is too long. There you go. Okay? Unreachable code. Forget you. It is reachable. Okay? Questions? So this is the last one. That's your last one. So 11 through 18, there's quite a bit of assignment, so don't delay.
You want to do the compatible zodiac
Yeah, you can just include it in there. So the Z, it's basically just to throw you off, a little extra piece of information, but it really is not going to affect much. So basically, okay, if you're Aries, you tell them you're compatible with these other ones, right? You just add a little, yeah, in the C out, yeah. Question?
Is it possible we could only just do one of them?
Why? It offends you?
But no, I mean just one, because lighting
No.
the whole thing is going to be high.
I don't care. Yeah, you got to do all of them. Sorry. If you do one, you're going to do one. You're going to get, how many points are in there? There's 15. You're going to get like
All
2 points out of 15.
Zodiac,
Yeah.
yeah.
Yep. Okay? Any other questions? Okay, so yeah, it's a lot of work. It's a lot of practice. But if you keep with it, you're going to be very good at it. Okay, that's the name of the game. You gotta practice this. You gotta put in a lot of time. It doesn't matter what your background is. It doesn't matter if you're like an English major or philosophy or whatever. Technically, or in my experience, the people with the most math have the easiest time with this. So if you've done all 3 semesters of calculus and differential equations and linear algebra, this stuff is going to be very easy for you to get. Not always, but generally that's the rule. Just to let you know, like look, when I was teaching intro to programming at Hartnell at some point, this Chinese lady took my class, right? And the very first assignment was one of these first assignments, like I gave the binary to decimal conversion and all that, right, in the first day of class. And she thought she was supposed to write a program to do all that for her. So she went home, she taught herself basically the entire semester's worth of class in one sitting on like the first day of class, and she did it. And I was like, wait, what? You taught yourself the whole class basically. But I wasn't supposed to do this. Her English wasn't that good. So she figured that's what she had to do, and I asked her, what's your background? She goes, oh, I have a bachelor's in applied math. I was like, this is easy for you, isn't it? She goes, yeah, it's like beginning, arithmetic, addition and subtraction. So the more math you have in your brain, the better it is for you to tackle these problems. But it doesn't matter if you don't have the math background. People from different backgrounds come up with very unique solutions. And like back in the day when programming just came about, a lot of people were getting into the fields from like English or whatever, and they would write very interesting code. So the code that an English major would write is really weird compared to how I would write it, but it's okay, right? It's still ways for you to solve the thing, and it all works. It's a learnable skill is what I'm telling you. It doesn't matter what you do. I mean, what your background is. If you put in enough time, you'll get it. Okay? It's just you got to put in enough time. Okay? So if you have any questions, you let me know, and yeah, just keep at it. And that's all. And by the way, one student already finished this class on last Friday. He's taking both of this class and my data structures class, which is like the next more advanced programming class. He does have background in programming most likely, but he already finished the whole thing. I had to go and grade like 70 assignments. It wasn't fun. Okay? So feel free to work ahead if you like. Okay? All right, so that's it. If you want to get started, question?
Yeah, on the bottom part of the code, the compatible, you said you have to do that compatible part?
Yeah, you just basically, let's say, all right, you figured out it's Aries, and you can tell them, oh, okay, you're compatible. Right? Tell them, yeah, you are compatible with these right here. So you're compatible with yourself and these other ones. It's just like a little extra piece of information just to mess with you in there. Okay? Yep. All right. So that's all I have for today. I am going to upload this for you, right? And if you're going to be writing these in C Lion, like with the way I'm doing it, remember, I would recommend just having one project with one main in there, right? And then you just go in there, copy all this stuff, right? Get like Sublime or something going. There's your Sublime. Paste all that stuff in there, and then save it as whatever the thing is. So I'm going to save this thing on the desktop as lecture 06, what's the date? 2017.cpp. Save it like that. And don't forget the comments on top and the bottom. Show me how the thing ran. And you're good. Okay?
Is there a student license to Sublime? I looked up and they want
It's
$70
free.
for it.
It's free.
Well, it's not in the unregistered yet. All right.
Mine is unregistered too.
Uh,
Yeah, I've never registered. The unregistered version will pop up with this little message. Hey, would you like to buy me? Like every maybe 20 times you try to save it, it'll show up like a little pop-up like, oh, would you like to buy me? And I just say nope, and then keep going.
All right, so
Yeah.
there's no trial or...
No, Sublime's free.
They called it an end-time trial.
And end time trials, yeah, that's why I like Sublime. Yes.
Just start off in Sublime and then copy it into the code blocks, is that what you're saying?
I'm saying that if you're writing your code in CLion, which is this, then you can, because it will always make this file main.cpp, just copy all the code from here, paste it into Sublime, and then save the code in Sublime with the correct file name.
Oh,
Yeah. And if you're doing it in code blocks, you can just make a new file, save the file with whatever name. There's no projects in code blocks. That's why I kind of like it better than CLion for introductory purposes. But yeah. What's up?
If you right click it and you refactor it, you can rename the main CPP.
I know, but then you're going to have to go and do all kinds of other things because it won't run the CPP. You have to go and look at the make file. See, this make file is actually connected to main CPP, so you have to go and edit your make list file to the other file name.
Mine does it automatically, I don't know how, but.
Not always. Yeah, it won't. It would be nice if it did.
So I've been submitting those, would that be fine?
Which one's the main CPP?
After you name them.
Yeah, as long as you give me the right name, I'm happy. Yeah, yeah, better that way. And then don't forget, back up all your work somewhere so that it's not just in this class page because the class is going to end when the semester ends. You might not have access to all your programs. And you want to have all your programs. Those are your tools that you know how to use, and then you can reuse them similarly in different programming classes. Okay? Any other questions? All right, that's all I have for today. If you want, get started, or if you want to take off, you can take off. It's up to you. Okay, thanks for coming.
I have a question on
What's up?
assignment 10,
Yeah,
the precision.
yeah,
So in that assignment, there was a goal to make the output exact as this. So
Yeah.
You wanted the results in a precision 1.
no, not all of them. So notice, they enter this with 2 decimals. This is 1 decimal. You're going to show them 2 decimals, 1 decimal. This one is 1 decimal. Then, when you show the next line, this is back to 2 decimals. This one is back to 1 decimal, and that's 1 decimal.
Right, and so I got stuck on that because shouldn't I be taking into consideration that the variables that they enter might be more than 2 decimals or might be more than 1 decimal?
It might, but let's just stick with the ones I have for testing purposes. It's more of an exercise to format things the way
All right, so
the
I
way
just
it
need-
looks.
I just need to set up the precision values for this test data.
Yes, sir. Yeah,
Alright.
and then use my numbers,
All right,
and then make it look exactly like it is. That will give you really good practice with precision.
okay. Yeah, I
Yeah.
got stuck on that because I ended up with like a 4.2 coming out because I had put the other values in precision 2, so then it was doing 4.20.
Yeah, you get rid of that 0.0, 4.20, turn it into 4.2.
Alright.
Force it.
Okay,
Yes?
all right, so
Yes.
just changing that variable all along.
Yeah.
Just for academic reasons, is there a way that when you set precision, it's that way until you change it again?
That's how it is.
Is there a way to turn precision off so that like you would see the float value at all times?
There's ways to do that, and honestly, there's a better way to do this with C format. C lets you do printf. So let's say, I don't know if this is gonna work. Let's see if printf works. I'll show you printf in there. I'll throw it all the way at the top so I don't have to enter things. Right here. So printf. Hello. There you go. Okay, so printf is how you do things in C, and C++ is backward compatible with C, and I like this format better than the actual cout is great for most simple things, but if you start formatting numbers, let's say you have a float a num is equal to 1.23456, something like that, right? In here I'm going to say a num is equal to percent %.2f, and then in here I'm going to do, I think it's a comma, and then a num. Yeah, whoops, forgot my semicolon. So what %.2f tells it is, %.2f is a float rounded to 2 decimals. So basically it will show, and if you don't do that, if you just do %f, then it will just be with the default number of whatever. I kind of liked it this way because with this one, it only forces something into a certain format just for right here, versus the other one with the set precision. Once you do the set precision, it's like applying to everything underneath it. And if you want to change it again, you got to do it in some other way. And by the way, this is how you would do this in Python. Python has a %f notation. If you want to go to Java, Java also supports this too. So I personally like the printf better.
Okay.
Yeah. So that's what I would do. Question?
So last week I asked you about maybe joining your Python class.
Yeah.
If I were to do that, would I be
I think it's already too late.
too late?
Yeah, because somebody was trying to join my data structures class, and I gave them an ad code, and admissions and records shut them down.
Okay.
Yeah, so if it's up to me, I'll be adding students all semester long. But it's just admissions and records are the ones who are just.
All right. I'll
No,
give it a
no
try,
fun.
and if it doesn't work, but
Yeah,
if I did, would
I
I
can-
still be getting like the grades and the point?
Of course.
credits and whatever?
Yeah, I don't grade things late. Remember?
Yeah.
Yeah. If it's late, as long as you turn it in before the end of the semester, it will get full points. As long as it's good.
Real quick, Marissa said that there's something going on right now, so when she talks to you, it's gonna be later tonight, so fine.
Okay, cool. Thanks.
Right on.
No worries.
There's a little L on the whole one and build.
I'll have a look at it right now. Yep. Let me unplug this. Man, can't believe I forgot to do the recording business. Broke my. Oh wait, it was recording. Yay! Stop.